I've always had trouble with CAPTCHAs, and I want to build an AI model that can solve them. How I want to overcome this challenge? Let's find out. So, first of all, I started looking for a dataset on Kaggle.com. It was the only dataset that I just found in the internet, but as you can see, it's a completed captcha image, and that's not only a character, and what it needs is a character. So now we have a big problem here, how to separate the letters and the numbers from this image. Well, here we have something called YOLO. It's incredibly powerful architecture that can detect the object in the image. YOLO wasn't originally designed for this task, so I had to fine-tune the model to my own dataset. So now we have a dataset and we are ready to make a model. But first of all, let me tell you what kind of model. Of course, we are going to make an OCR model, but let me tell you what is it. The text recognition feature on iPhone is also a type of OCR, and you've probably all used it. After inputting the image, we apply a convolutional with two 5-5-1 filters and real view activation, followed by max pooling with 2x2 pool size and a stride of 2. Next, we perform a second convolution with 4 free 2 filters using sigmoid activation, followed by another max pooling. The output is then flattened into 100 nodes. Finally, a fully connected dense layer processes the data and generates the predictions. But to build such a model, we need at least 10,000 data points, while the dataset we had only had 5,000 and a half, which isn't enough for image processing. Cross-image data generator augments a small dataset by applying random rotations, shifts, zooms, shears, and brightness adjustment, and fill value with 170, and it will be expanding it to over 118k images. So now we have a data and we just need to train our AI model. As you can see here, we have 118,000 of data. That is a lot. In the size, as you can see here, is 52 pixels in 32. And here's a sample image. And we have the labels for each classes. And now we just need to design our neural network structure. The first layer of the sequential network is conv2d. It's a layer that it will extract the features from the image, and each conv2d layer is followed by max pooling 2d and batch normalization and dropout. And dropout layer will prevent the model to get overfit. And again, we just repeat the layers, and after that we just flat the output and get it into a dense layer, 2 dense layer, and the last one is the numbers of the classes that we have with the softmax activation for learning. And then here's a summary of our network. As you can see here, we have totally 489,000 parameters. And in the last epoch of training, you can see that we just get a really good accuracy. And if you want to visualize it, you can see that It just gets so good. And so now it's a time for testing it. So I have a piece of code here that randomly it will select and choose an image, the CAPTCHA image, and it will process it. So let's try one with this code. Running it. And so now we have a sample image that, as you can see, if you want to guess, is 2AYN47G3. And alright, as you can see here, the YOLO model just do its job really well. As you can see here, it just detects all the numbers and letters. And for predicting part is exactly 2AYN47G3. And it's perfect. Let's try another one. Okay, another one is 57FB4GW5. 57FB4GW5. Now our AI model has a really good accuracy.